All right, everybody, here is the problem I'm most concerned about on the test. It's when you have two sides and then an angle that's across from one of the sides, okay? And we said we're going to set them all up the same exact way. So that's going to be part of the test. Are you setting them up the way that I want you to set them up? So let's talk about that for a second. I make the ground. This is, remember the story, this is where the snowy ground was. And the reason why I'm doing this is so that we can see which angle is the one that can change and can pivot, if you will, and the one that's fixed. So this is where the tree was. That sucker is not moving. The tree is fixed at an angle over here of 20 degrees with the ground. So you put your angle on the left. You know, some people kind of, that rubs them the wrong way. They're like, well, why can't I put it over here on the right? You can. It's just not going to get full credit on the test because it makes it harder for all of us to see in some common way what the angle is that's changing, okay? So what's across from that 20-degree angle? Well, the side that's across from the 20-degree angle is the one that has the same letter, right? The lowercase a. So I draw my 3.5 over here, and maybe I'll label that A. This is our angle A. And then I want you to put the B side right here. So B equals 5, okay? Could you put the 5 down here? Yeah, you could. But then we got to think about, well, what angle is pivoting and what angle is changing. And here it's easy for me to see you've gone up, whatever, 5 yards up the tree. You tie a knot, you know, maybe the tree keeps going. That's fine to consider. And you tie your knot in your rope, and this is the angle right here that can change. The rope can swing on that angle, right? I mean, like this could stay 3.5 yards long, this could stay 5 yards long, this could stay 20 degrees, and this could change, couldn't it? Couldn't it like swing over here? That's not the only place that rope could be tied to the ground or anchored to the ground. You could have it over here too, potentially, right? So let me draw in what possibly could happen here. And here are the two triangles that we're talking about. One of them is right here, okay? There's one of the triangles. And it would have a side length that's equal to 3.5, another side of 5, and an angle at 20 degrees. And the original triangle that I drew on the screen here was right here in blue, right? So it has a 3.5, a 5, and a 20 degree angle right down here as well. So we want to find the blue triangle and the red triangle. If there is indeed two triangles, there's a chance there's no triangle at all, or that there's exactly one triangle. So how do you figure that out? Well, you set up the law of sines, and I'm going to find angle B over here first, and I'm going to put the sine of B in the numerator just because I think it makes my arithmetic a little bit easier, or at least it makes it less for me to say when I'm trying to describe how to solve for B, because all I need to do is multiply both sides by 5. Okay, so if I put a 5 right out here, the 5's here are going to divide out to 1, and then I put a 5 over here, and I'm going to do that on my calculator, right? I'm going to jump over to Desmos. I'm going to do 5 times sine 20. And by the way, I just opened up Desmos. You guys are doing a great job remembering to switch to degree mode. I wanted to do, what was it, 5 sine 20 divided by 3.5, I think. Let me go back and look. So I'm doing 5 times sine 20 all over 3.5. And I'm putting the 5 out front. You know, sometimes, like in my algebra, you saw that it was like times 5 over here. That's dangerous because it might think I want the sine of 100 degrees, okay? So I'm a little worried about that. So what if I put the 5 over here? Oh, see how it did change my number. My number before was 0.2 something. Now it's 0.48 something, right? So this right here tells me I've got two triangles. Why does it tell me I've got two triangles? Well, because I can take the inverse sine of 0.48, whatever that was over there on the screen. And that's what I'm going to do next. I'm going to take the inverse sine of the 0.48 business, right? So See, right here, I can do this. So I step back out front, and I now know that I have two triangles. So what I'm going to do is I'm going to call this one B1. Oh, shoot, what the heck? I thought I had my cursor in the right spot. Get over there. B1 equals, okay, inverse sine of that business that I got going on over there. Okay, so now I've got it recorded in Desmos, and I can put it as accurately as I need it, right? 29.2, I think it was. So my angle B, and probably the best way of writing this is the measure of angle B is equal to 29.2, I think it was, wasn't it? Yep, okay. So I think on the test we'll round to the tenths place. Well, what do we do after that? Well, this is 29.2 right here. I'm going to label it B1. And then my B2 is going to be right in here. Do you see that? That's my B2. Well, if this right here is 29.2 degrees, because we've got an isosceles triangle, when you have an isosceles triangle, 3.5, 3.5, the base angles are equal to each other. Like I guess I could mark those equal, so you put like the same kind of tick marks in them. And so if this is 29.2, then this over here is 180 minus the 29.2. So we come down to this line, B2 equals 180 minus B1. I mean, I don't see a reason for copying and pasting this down here because I've got it labeled right there. So the computer's using that. And now to find my C1, I think it was C, wasn't it? Yeah, because this is A, right? So right up here, my C1 is going to be in blue. So this thing right here is my C1. And then in red, I've got my C2 right here, okay? So let's jam those out. C1 equals 180 minus 20 minus B1. And then C2, I guess I could copy this stuff right here, right? Boom, Control C, Control V, and then just change this 1 to a 2. Okay, so I've got all that now. I've got my angles. I've got my, I guess I don't have any sides yet. Okay, so I've got to find over here C2, little C2. That's a lowercase C2, and then I've got to find C1's side length, right? So that's this whole side over here. I love it when that little menu stays on. So how do we do that? Well, let's see. I've got to do the law of sines again. So well, it would be I want side C1 up in the numerator so that I make my life a little bit easier on me. And that's equal to, I guess I'd use probably the 20 degrees and the 3.5. So I'd go 3.5 over the sine of 20 degrees. Then I just multiply both sides by the sine of C1, right? So I've got C1 is equal to 3.5 sine C1 all over sine 20. Okay, so let's jump over here and put that in right here. So let's see, what did I say? C1 equals fraction bar. Oh man, 3.5. I'm looking, my eyes are looking right there. 3.5 sine C1 over 20. 3.5 sine C1 over 20. What? No. What was it over? What was it over? It was over sine 20. Man, what am I doing? Sine 20. Okay, so there's my C1 value right there, 7.75-ish. Okay, now I'm going to go for my C2 value, so C2, and the nice thing about that is I can just copy and paste this guy, and then just change my C1 to a C2. Okay? Hey, I hope I'm making this clear. I've now found all the parts of this triangle. Now, let's talk about how might you have a no triangle situation. Let's say instead of 3.5, okay, so I get rid of the 3.5 up here, and let's say this was, I don't know, 1.5, okay? So where is that back here that I did my little calculations? Remember how I had the 3.5 down here? What if I change this to a 1.5? Well, see how it's undefined now? So if it was 1.5 right there, this wouldn't be long enough to reach the very bottom, to reach the ground, to reach the snow. You'd have a rope swing up here that is way too short. So it would be like, you know, hanging down here, and it would be swinging back and forth and never reaching the ground. Now maybe that's good for a rope swing. You don't want it to hit the ground, right? That's uncomfortable. So you know, but it doesn't make a triangle. It doesn't make 3 complete sides with 3 angles and all that kind of stuff. It would just have this side swinging around up here, and you'd run into the tree over here, I guess. I hope I'm making this all clear. This is a very challenging problem. Thanks for watching my video. I guess, you know, if I was going to say there's well, there's probably 2 keys to this. You've got to recognize that it's a little side, big side angle situation. So it was a littler side, a bigger side, and an angle situation. And then when you set up the law of sines, why are we setting up the law of sines? Because we have a matching pair of opposite pieces of information, an angle and a side. Once I set up my law of sines, if it gives you an angle, like it gave us 29.2 degrees right here, then you have 2 triangles. If it gives you an undefined situation, like I just modified it, it's no triangles. If it gives you a 90-degree angle, that means this side swings perfectly down and hits in just the right spot to make one 90-degree triangle. Okay, so you got to pay attention to that. Thank you very much for watching my video. I hope that helps.